Okay, so at the start of this chapter, we'll be talking about quadratic functions, and we'll be talking about it in a couple different forms. But let's dissect the quadratic function graph, which would be a parabola. Hopefully you recall the parent function of a quadratic is f of x is equal to x squared, and we can see that the vertex, okay, which is like the in this case the bottom of the U shape of the parabola, is located at 0, 0 on the parent function parabola. There's also another line known as the axis of symmetry. And what the axis of symmetry is it's an invisible line that cuts the parabola vertically in half, so that the left side is symmetrical to the right side. And we'll be using that. So um, we can expand on the quadratic function as far as, the standard form, and it can be written as a equals, or a g of x equals ax squared plus bx plus c, which is one you're probably familiar of seeing in algebra 1. And we saw another form when we first talked about parent functions. So we'll be looking at the both of these forms and another form as well. We want to make sure though that our b value is equal to 0, and in that case the vertex lies on the y-axis. So let's take an example here. Here I have y equals negative 1/2 x plus 4. Now, from our previous discussions of quadratic equations, we can tell that we can tell a few things from this equation here, just in the way it looks. Like, for example, it's shifted up 4 with the plus 4. And it's going to be reflected, meaning it's going to be opening down, and the 1/2 tells it's going to be a vertical compression or vertical shrink, so it'll be wider than the parent function. But what we want to do is accurately graph this, and I'm going to show you one method in which you can graph this. And what I need is I need at least 5 points. So like on a test or quiz, when you're asked to graph, you need to give at least 5 points, and we can just pick some arbitrary x values with this method. So we're just going to pick x values. Negative 2 to 2 will be fine. We can tell it's not horizontally shifted because we don't have any h value, and there's no h value in this form anyway. So the way we'd go about this is just we would substitute. Let's say we'll start with negative 2. So I want to find what is y when we have negative 1/2 times negative 2 squared plus 4. So y is equal to negative 1/2, and then that's going to be times 4 plus 4. Scrolling down, I can continue this. Y is equal to, and then this is going to give me negative 2 plus 4, and thus y is equal to 2. So I'd go back and I would fill that value out in my table, and we said that was going to be 2. Okay, and then we would repeat that process. We would, we would substitute in -1 and 0 and 1 and 2. I'm going to go ahead and just fill out those values. Now you would want to work these out and show your work if if you're doing an assessment. So let's go ahead and fill that out. So when x is -1, y is 3.5. When x is 0, we can surmise that's going to be 4 because that's where the vertex is going to be, as we can see with the +4 at the end. +1 will give us a y value of 3.5, and then 2 will give us 2. So let's plot those points. So -2, +2, -1, and then positive 3.5. So 1, 2, 3, and halfway between 3 and 4. 0 and 4. And then it's going to be symmetric. So I really don't even have to look at my values for this one. Okay, so now that I have those, I can go ahead and draw my parabola. It's going to be a bit challenging for me on this. Make sure you extend your parabola the length of the graph, and of course don't forget your arrows. Okay, so that's one way in which you can graph a parabola. Just substitute in x values, find the corresponding y's, plot those points, and draw your parabola. So basically, there are several properties based off the parabola and based off the quadratic equation in standard form. Remember, this is this ax squared plus bx plus c is standard form. And so, like for instance, here I have a parabola that's opening up because the a value is greater than 0. But I want to also point out that you have an axis of symmetry, and that always goes through the vertex. The axis of symmetry always goes to the vertex, and that's why it bisects it into two parts. But the axis of symmetry can be found by this equation of x equals -b plus 2a, where b is the coefficient in front of x and a is the coefficient in front of x squared. That's going to come in handy. Additionally, the y-intercept in standard form is always going to be 0c, where c is your constant at the end. Likewise, I mean, I can see it here. Again, the axis of symmetry is x equals -b over 2a, and my c value is going to be, or my y-intercept is going to be 0c. That corresponds with the constant in this equation. And this opens down because our a value is less than 0. aka it's less than 0. It's a negative number. Now, if it opens up, the vertex is regarded, the vertex would be here and is regarded as a minimum. Okay, and this is when a is positive. If it opens down, our vertex is regarded to as a maximum, and this is the case when a is negative. So you'll be asked to identify from an equation if what type of vertex is it? Is it a minimum or is it a maximum? Okay, so let's graph an equation in standard form, but let's take a different approach. Instead of just plugging in, a whole bunch of points, let's take a slightly different approach. So the first thing I want to do if I want graphing something in standard form, is we want to, the first thing I want to do is I want to, get the axis of symmetry. Axis of symmetry. So recall that's x equals negative b over 2a. Notice it's x equals because the axis of symmetry is a vertical line, and vertical lines are graphed when you have x equals a constant, x equals a number. So let's get that axis of symmetry. So x equals, now our b value is going to be 6, so here's negative 6 over 2 times a. Our a value, since it's a negative in front of the x squared, is going to be negative 1. So we would evaluate that as being negative 6 over negative 2. Therefore, x is equal to 3. Okay? And that's going to be our axis of symmetry. I'm going to go ahead and draw that in. We draw the axis of symmetry with a dashed line because it's not actually part of the visible graph. It's just a guide. I mean, it's something that exists, and we use that as a guide to help us graph our quadratic. Okay, so now the second part is we're going to find the vertex. And it's easy to find the vertex because it lies on the axis of symmetry. It's somewhere on this vertical line. We just have to figure out where exactly. So here's where we substitute our x value in order to find our vertex, to find our y for our vertex. So it's y equals, and then negative 3 squared plus 6 times 3 minus 8. Now I want you to keep in mind I'm substituting in a 3. Okay, the negative is applied to the 3 after you square it. Okay, because assume that's a negative 1. Remember, you do exponents before you do multiplication. So when I evaluate this, this is going to be 3 squared, which is 9, and the negative makes it negative 9. Okay, plus 18 minus 8. Now we're going to work that out. So that's going to be 9. Negative 9 plus 8 is 9. Minus 8 is going to give us 1. So my vertex is located at 3, 1. Okay, and I'm going to underline that. So 3, 1. There's my vertex. Okay, so we have the vertex, so we need 4 more points because we need a total of 5 points. Now to get the other points, we're just going to go back to substituting in values. So I'm going to pick I'm going to pick values to the left. You could pick values to the right. It doesn't matter. But I want to be smart about this. If you recall, the y-intercept here is going to be at negative 8 on the y-axis. In other words, it's going to be 0, negative 8. So in my work, we're going to get other points. And I'm going to build a table. So x and y. So when x is 0, y is -8. And again, we just get that from the equation. So there's really actually no calculation required for that. So I'll just go 0, -8. So 1, 2, 3, 4, 5, 6, 7, 8. And I'll pick that point. Now I want to get another point on the left side here. And I kind of need to think logically about this. What point do I want to use? I don't want to use -1 because I know that this graph is opening down, and it makes sense. My vertex is up here, it's at the top, it's a maximum, and in our equation we can see that we have a negative in front of the x squared. So it's opening down, and so the next point is going down. So -1 would take it off our graph, so we need to pick something like 2 or 1. Okay, so we want to pick 2 points either to the left or to the right, and it helps to pick points that are on the same side as the y-intercept. That's why I'm picking points to the left. So I'm going to go ahead and choose 1 because that'll be an easier number to work with. So let's see, -x plus 6x. So I'll substitute in 1. So y equals, and negative, and then 1 squared plus 6 times 1 minus 8. So this is simply -1, because we square the 1 first and then we apply the negative. Remember, put parentheses around the numbers that you're substituting in. That'll help eliminate sign errors. It's not a guarantee, but it helps. And so that's going to give me 6. So -1 plus 6 is 5, minus 8 is -3. Which makes sense because it's not as low as -8, but it's not as high as 1. It's in between. So on my table, I'm going to put in 1 and -3. So we'll plot that here. 1 and -3. Okay, now that's all the plugging in we'll have to do, because we're going to use the property of the line of symmetry. Again, it's a very useful thing to help us, graph, and we're going to use a property that, it cuts the parabola in half. It's symmetrical. So since I'm going to look at this point and I see that, oh, it's, line of symmetry is 2 units to the right of it. So that means the next point, which is symmetric to this point, is going to be 2 units in this direction. So I would plot that point, which looks to be about, what, 5, -3. And then we do it for the other point as well. So I can see that, oh, hey, this is 3 units in this direction, so I go 3 units in this direction. And that's going to be 3 units there. So I'd plot that point, and we have the required 5 points that we need. So I'm going to go ahead and connect those and get my parabola. So here, this is lousy. Like I said, it's really hard to do it on this wireless pad. Much easier to do it on paper. Okay, so anyway, that's more or less the parabola that we are looking at. Or this is the parabola that this graph equation will produce. Okay, so let's look at one more thing. Let's say we want to find the minimum or maximum value of y equals negative 2x squared plus 4x plus 3. But we want to do it without having to graph it by hand. So there are a couple of ways of doing it. One way would be to find the axis of symmetry and then find the y value. Just like we did with the last equation, that would give us the vertex, and then we can see, because this is a negative equation, or the a is negative rather, it's going to be a maximum. So it's going to be opening downward. We could do it that way, or if we have a calculator available to us, and we do, we can use that. So here's how you can do this on a calculator. So the first thing I'm going to do is graph the equation. So negative 2x, and what was it? Plus 4x plus 3. So plus 4x plus 3. Okay, so now we will graph it. Oh, my mistake. I forgot to put the squared. So I'm going to go second, insert, squared. Now, that's why we're getting a line. Okay, so now I have my parabola. Okay, so I clearly see it's opens down just like we anticipated, and the vertex is going to be a maximum. But instead of having to find the axis of symmetry and then plugging in the axis of symmetry, the x value, into the equation, then finding the y value to get the vertex, let's go ahead and do this. We're going to press second, and I hope you're getting this down, and then calc. And here we're given a list of values, or a list of options, and what we're trying to do is we're finding a maximum. So I'm going to select option 4. Now, your calculator is going to ask you, left bound. It's asking, where should I look for this maximum? Set the boundaries, because it's not going to necessarily look at the whole graph. So you got to tell it where to look. So left boundary means I want, it's not going to go any further to the left than where I tell it to. So I can use the left and right arrow keys to move this cursor along the the graph, and I want to move it just a little bit to the left of the vertex, and then I'm going to press enter, and a little arrow pops up. It's hard to see, but a little arrow pops up denoting that, and then it's going to ask for the right boundary. Okay, so I'm going to arrow to the right, just a little bit to the right of the vertex, and I'm going to press enter, and as you can see, there's a little arrow that pops up here, and it's going to look, so these are the boundaries, so it's going to look for the highest or the highest y value, the maximum between these two arrows, and that would be, hopefully your vertex would be in there. So then I'm going to press enter, and then we can see right at the bottom, it says the maximum is x is equal to 1 and y is equal to 5. So therefore, in our answer, we're going to say, oh, it's a maximum of y equals 5. Okay, so that's how you can use a calculator to find minimum or maximum. Anyway, that concludes graphing and using standard form of a quadratic. Next time we will hit two different forms. See you then.